Hello, everyone. I am Wes Purvis. I do wireless things at Mist, and this is the wireless portion of our Mobility Field Day presentation. So I would be remiss if I did not talk about Wi-Fi 7, since that is the current hotness in our industry. And of course, I think everybody is familiar with this number, 46 gigabit per second, right? This is the speed that you can expect on Wi-Fi 7. With a 320 megahertz wide channel, right? That's 16 bonded channels, right? It's a very wide highway. You have 4K QAM, which yeah. So I mean, all jokes aside, I mean, think about this number though. Think about the beginnings of Wi-Fi, and to the point where we are now. I mean, this is seriously impressive. It's actually pretty cool. But if you break down, that number, right, that 46 gigabit per second, right, that is 16 spatial streams at 320 megahertz wide channels. So I think most of the people in this room and most of the people watching will not be able to deploy that because we're expecting most enterprise APs will not be 16 spatial streams. There will be no missed 16 spatial stream Wi-Fi 7 AP. I regret to inform you. Yeah, so let's think about, okay, what is actually more realistic? So from a Wi-Fi 7 enterprise AP perspective, we're expecting that aggregate data rate on the AP to be 26 gigabit per second, which is not quite 46, but it's still like a really big number, right? It's a lot more than 11 megabits per second. So, but okay, that's like, across all the radios. So what is the actual kind of realistic expectation of Wi-Fi 7? So if we assume our clients are two spatial stream, which they have been for, since mostly 11AC, but definitely 11AX. So two spatial stream at M13, right? So that's the 4K QAM rate. The EVM for that is neg 40. So you better be right, right by that AP. But assuming you can get that M13, right? So at 80 megahertz, single client data rate of almost 1500 or 1.5 gig, right? 40 megahertz, 688 megabits per second. 20 megahertz, 344 megabits per second data rate, right? That's the data rate. And of course, we all know that, actual throughput because of Wi-Fi overhead will be, about half or 60%, maybe a little bit higher if you're in good conditions. But this is the more realistic expectation. You could see a modest speed bump of single client performance with Wi-Fi 7, right? Just by, if you're just looking at that data rate number. Now, there are other features in Wi-Fi 7 which we're excited about, like MLO, like static puncturing, like some of the enhancements to multi-resource unit usage. And these are things that we're not quite sure how well they will actually work, right? And so some of the things like MLO have actually looked, encouraging in the lab, but that's the lab. So if you think back to the previous generations of Wi-Fi, like let's go to 11AC with multi-user MIMO. Multi-user MIMO also looked really promising in the lab. In fact, if you go search on the internet, you will find a video of me doing a lab test with multi-user MIMO and it looking really good with a video stream test. But once you got into the real world, some of the overhead and it just never really worked all that well. On the other hand, with Wi-Fi 6, you have OFDMA. OFDMA has actually been solid, right? Especially downlink OFDMA. It happens all the time. Uplink is a little, still a little bit tougher to schedule, but you will see it. So, we're hoping that MLO will trend more like OFDMA, but we're not there yet, right? We don't, and we won't know that until there's, more, production deployments with, with clients. And so this will take a little bit of time to vet out. And so for us, the way that we think about things is Wi-Fi 6, 6 gigahertz Wi-Fi. And so where are we with 6 gigahertz Wi-Fi? Well, in the past few months, we have seen a large uptick in adoption. When I say large, we've gone from, let's say, 10% in many environments to some environments where we're now seeing 20 to 30% 6 gig adoption. So here's just a couple screenshots that I grabbed of, okay, this particular customer and this, in this site has almost 18,000 clients. Almost 4,000 of those clients are on 6 gig, right? That's really cool to me. It's cool to see how things have increased, right? If we think about Wi-Fi 6 clients, it took probably 4 years to get a meaningful client adoption. So we're still on that journey with 6 gigahertz clients, but we're in the middle of that journey. Here's a small site, 65 clients, but 12, right? 12 on 6 gigahertz. And here's another one with 3,500 clients and over 1,000 of them on 6 gig. So this is real life, right? This is 6 gigahertz is here, it's working, and we're starting to see clients. I mean, we're even at the point where in the US we have 1,200 megahertz of spectrum, and we've kind of defaulted to 80 megahertz channels. In some cases, we're thinking, should we go down to 40s? In Europe, where we have 500 megahertz of spectrum, we kind of, we usually do 40s. We're thinking, should we go down to 20s? So that adoption is something that we're seeing, and definitely really excited about. Like, I was even in my local grocery store, of all things, and I look, on my phone, and oh, I'm on 6 gig, right? It's an OWE SSID, OWE transition, but this is just, I don't know, 6 gig is happening. It's all around us. The point is the technology has matured, right? Over the last year and past few years, it's okay. What's it going to be like? Right? This is kind of, we're on that same journey with Wi-Fi 7, and we'll get there. We'll get to maturity. It just, we're there now with 6 gigahertz.
Did you grab the right sausage?
I did have to check. And here's another example where on some of these APs, there's actually more 6 gig clients than there are 5 gig clients on that AP, right? So here, this top one, 45 clients on 6 gig, 41 clients on 5 gig. So this is why, that 20 megahertz, 40 megahertz, 80 megahertz channel width, discussion becomes more relevant.
Breakdown what kind of clients those are seeing that uptick from?
So for this particular example, it was predominantly smartphones. Apple and Android. But in some of our other customers, it's the laptops that are causing the adoption. So that brings to the next topic, which is automated frequency coordination, which is related to 6 gigahertz Wi-Fi. So as probably most are familiar, basically any 6 gigahertz deployment out there today is in the low power mode, low power indoor, which means you have to deploy indoors at a low power. There is another mode of operation called standard power, and standard power requires the use of a frequency coordination system. And the FCC, as of end of February, has approved several AFC providers. And so standard power AFC is open for business. Now, there are special requirements that go along with it that I'll talk a little bit about. And from a client perspective, the client has to be certified to connect to a standard power access point. So, and there's basically three types of clients, but two that we'll see most commonly. One is a low power only client, which means I will only connect to a low power AP. Then there's also the standard or dual client. And that dual client can connect to both a low power and a standard power AP. And what we've seen is the initial clients were low power clients, and now most clients that are certifying as dual, and some client vendors are going back and recertifying, but not everybody. So the thought is you'll have pretty good client support, but may not have every client support in standard power mode.
Wes, since this is relatively new, end of February, all the 6 gig clients out there, is that a software firmware update, or is that something that is just going to be not compatible?
Yeah. So from a from a client device, right, the client device needs to be certified to connect to the standard power AP. And so clients have been able to certify as standard power or dual since 6 gigahertz was approved in the US. So there are many clients out there already that are certified as dual. Some are going back and recertifying. Once they're certified, they can do a software update to connect to a standard power AP.
Now, are customers engaging Juniper to report energy efficiency metrics with the implementation of the standard client? Is that something that's on the roadmap? Is that being discussed?
When you say energy efficiency, you mean like the power on the phone?
Yes, as well as power on the AP itself.
So
overall,
yeah. So when I say low power and standard power, the actual power consumption of the AP is not all that different. Right? There's different allowed RF transfer power, but the several dB of transfer power it's not all that much in terms of actual wattage, like consumption on the AP.
All right.
Okay, so how do you determine, or how does a client determine if they're connecting to a low power AP or standard power AP? Well, you look in the beacon. The beacon has a regulatory info bit. 0 means indoor, low power indoor. A 1 means standard power. You may also see a 4. But the client uses that to determine can they connect to that AP. There's also a transmit power element, IE, in the beacon that tells the client what transmit powers it's able to use. And that's especially relevant for standard power, where the allowed transmit power may be dynamic. So why do we have an AFC? Well, it's because 6 gigahertz was previously and remains a licensed spectrum. And so extensive studies were performed to say indoors, in the low power mode, there's no possibility of interference, right? You're not going to interfere with the incumbents. And the incumbents are typically fixed microwave links, point-to-point service, some of the local TV news stations, the TV band that can be in 6 gigahertz band. But in outdoor usage, there is concern around interference, and probably rightly so. And so that's where the frequency coordination service comes in, is to say, based on your location, I'm going to look in this database. There's a database of all these licensed users of their location, the antenna pattern, and the transfer power they're allowed, and all that stuff. So combine the AP location, the Wi-Fi AP, with the incumbent location, and run some formulas to say, all right, you can use these channels, you can't use these channels, you have to pull back power a little bit. So that's why we have a frequency coordination service in 6 gig. If you go on the FCC website, there's the universal licensing system that you can actually go search, in your local area, what's around. You can see all the links. If this one's a point to multi-point, what frequency they're operating in. And so the AFC system has been standardized thanks to the work, from Wi-Fi Alliance and WinForum. And so generally the pieces of the puzzle, you have the access point, you have the AFC system, and then you have the licensed databases, the FCC databases. So the AP talks to the AFC provider. The AFC provider has the FCC database information and has the formulas, and those formulas are defined by the FCC of the calculations that need to be performed. So the AP is sending location information, and typically in most enterprise deployments, there'll actually be a proxy in the middle. So the APs aren't necessarily talking directly to the AFC system, and like in the case of Mist, our cloud is actually acting as the proxy to communicate the AFC information.
So we don't have to open up any new ports on the firewall. Don't have to do any of that garbage.
Correct. Yep. So from the AP, what are the requirements that the AP needs to follow? Because ultimately it's the AP that needs to comply, right? So first of all, the AP needs to have an AFC update every single day, every 24 hours. Now, if I don't get an update in 24 hours, I'm allowed to continue using my 6 gig channel until 11:59 of the following day. So I don't have to cut off right away. Let's say, for whatever reason I lose connectivity to Mist Cloud, or by extension the AFC provider. So yeah, if my 24 hours expires, I have until the end of the next day when I have to shut off. I need to provide my geolocation, and that geolocation has to be determined automatically. It cannot be manually inputted. So most commonly, this will use a GNS or GPS receiver within the access point itself, or it could not necessarily every access point has to have that receiver. You could kind of pool, if the, APs are deployed in a similar area. You also have to report an uncertainty area, which is how, I think I'm in this location plus or minus 20 meters or plus or minus 5 meters, right? That's your 90% confidence. You need to provide your height above ground level. You have to provide a unique device identifier, which is typically serial number. And you also have to provide, or if the AP has lost power, it needs to either provide new location coordinates or say, I have not actually moved, right? It needs to be able to make that determination.
So for this uncertainty value in step 2,
Yeah.
what is there a maximum uncertainty value? Can I say, hey, this is what I expect with an uncertainty of 1,000 miles, and boom, I've cleared the entire state or something like
You can.
that, right? You can.
You can do that, but
Okay.
you'll likely
Get all the AFC incumbents and everything.
you might have a lot of restricted channels.
Okay.
For Stan, oh, shit.
Does the operator, the network admin, have to put in these details, or will the AP automatically have some device that determines all this?
So GPS, the geolocation is automatic. The only one that you could enter is the height above ground level, and so depending on how the AP is deployed, right? There's a some of the APs have a barometer that can determine height, but you could also enter it in.
Is that
Uncertainty value based upon anything other than what the person that's putting it in? It's not tied
No,
to
no,
the scale of
Nope,
anything?
nobody is entering that.
Okay.
That is
So
that is
it's
automatically.
It's kind of like a client going algorithm.
Yeah.
Like it's inherent to the.
So like as we
GPS location.
Okay.
like as we're going through our regulatory approvals, we actually have to go to an FCC lab and test the GPS chip that's in our AP in a variety of locations. We actually have to go to multiple locations.
So the GPS chip has that uncertainty value
Correct.
built into it. Okay.
Right.
well, I was tagging on those questions. So CPI certification was a big deal a couple of years ago for all the stuff that happened in CBRS. Is there no certification process? There's nothing
No,
you have to do?
because the geolocation is automatically determined. There's no CPI or professional installer requirement.
That's the difference that makes this different than SaaS, is that that requirement's not,
Correct.
that you don't have to
It's-
manually put stuff in.
It's a blessing and a curse.
I got a question from German. Can a bad third-party actor trick the GPS system so much that it can force the SPAP offline?
Potentially, right? I mean, if you're jamming GPS,
Oh.
you're going to cause a lot of problems for a lot of people. But yes, inherently it relies upon GPS location. Okay, so from a standard power client, perspective, like the AP obviously can operate higher transit power, but the clients can also use higher transit power. So initially there's some confusion around that. There's a 6 dB offset, right? Is that 6 dB below the AP's operating level or the granted level? And it's the granted level. So it doesn't matter what the AP is operating. The client can use 6 dB below whatever was granted. So in theory, the client can have higher transit power in standard power mode than low power mode, which should help in some deployment scenarios.
You're not seeing many standard only clients?
No.
Okay. Glad to hear that.
Yep. So what does the spectrum request look like? Well, it looks like this, and it's all standardized. Basically providing serial number, type of request, my certification ID, what I'm requesting. So my location, my uncertainty, my height. You can actually provide location as an ellipse rather than just a single coordinate, and then what frequencies and what operating classes. The operating class is the bandwidth. And so, in MIST, we request every operating class just so we have the full data set. So do we actually care about AFC? So certain use cases, yes. So 1, outdoor, you have to use it. 2 is external antennas, field installed external antennas, you have to do it. And then there's actually discussion, do you care about AFC indoors? like in a normal indoor deployment, would AFC, would standard power mode on the AP actually benefit you? And the thought is because of that higher client transit power, there could be some benefit. So if we look across Mist, and I showed this data at WLPC, the average RSSI of every client across Mist of how the AP hears the client is negative 55 dBm. That same value in 6 gigahertz is negative 64 dBm. Right? So there's a 9 dB, right? These are all low power clients. But what we've seen as we look at our Zoom and Teams data, as we look, at our experience data, this isn't terrible, like all that relevant. In most of our deployments, which are capacity based, right? So you have an adequate density. If you're in the main part of the cell, right, this is perfectly fine. But if you have a less dense deployment, or you're at the fringe of the cell, that's where this additional transit power for standard power could help. So we've done some testing, and we need to do a lot more testing, right? We're at the very beginning of this kind of theory of, is standard power actually beneficial? But this is a Pixel 8, and there's about a 3 dB, 2 to 3 dB difference of how the AP hears the client when operating in standard power mode and low power mode. So 3 dB, I mean, it's 3 dB, but is it worth there's a lot of effort that goes into AFC, there's a lot of baggage, let's say, with the geolocation and, especially indoors, populating, GPS location. So, and this is just one client, right? So, at least my feeling is indoor standard power is more of a niche use case than an everyday use case, right? You may have scenarios where you have less dense deployments, right? You have more of a coverage deployment, or you're worried about fringe of the cell, and that's where standard power can help indoors. In addition to the 2 use cases that you have to do it for.
Warehouses, places like that.
Not necessarily
large coverage areas.
Yeah.
Low density.
Yeah, I mean, even in like a warehouse where you like, if you have line of sight, right? Like many of our warehouse deployments, warehouse antenna pointing straight down, a couple of antennas in the aisle, right? I have line of sight. I don't need. Well, okay, it's external antenna, so probably I will. But assuming it wasn't, like, I'm not envisioning standard power.
Well, maybe I'm thinking like cannabis grow facilities.
Sure.
You've got huge areas,
Sure.
right? And just you've got sporadic devices everywhere, but you're going for more coverage than anything else. So you need that extra 3 dB. Because 3 dB, I mean, it's half power.
When you say it, when you see standard power indoors as being sort of a more corner case scenario, do you see any risks? I guess the biggest risk of just simply launching with standard power off in the first place is what, client compatibility?
Client compatibility.
And so assuming the client compatibility hits a critical mass where that's not an issue, you wouldn't really be heartbroken about recommending standard power across all.
No, I mean, and you can deploy a dual band SSID, so you just fall back to 5.
Fall back to 5, yeah.
Or, so the other thing is you lose, you can, in standard power, you have Uni 5, Uni 7.
Oh, you lose channels.
Yeah, so you lose some channels.
Okay.
Yeah.
But output power of the radio is not different.
It could be slightly higher.
Because like to Ron's point, right? If you're running standard power versus low power, can you disable certain elements in the access point to save energy?
I mean, yeah. So
there's like a diminishing return there. It's like, well,
So the AP, just because the AP is allowed to use the higher power, it doesn't have to.
Yeah.
Right? And most of our deployments we're reducing power anyway. Yep. Okay. So I'm getting the speed up from Sadir.
Take notes.
So we're working on our AFC approval. But I just want to give you a little preview of what goes kind of behind the scenes. This will be our first AFC AP, standard power AP, AP64, which is our outdoor AP as built-in GPS.
And it will support external antennas?
No.
And 16 spatial streams?
And this is a Wi-Fi 6E AP.
6E, okay.
Yep. Okay, so then I'm going to get to the stuff that Sadir actually wanted me to talk about. So let's talk about redundancy and deploying redundantly. So Mist has had tools for determining have you actually deployed redundantly. So if you've ever seen Mist, this is a switch view that we have. In the switch tab, you just go to location, and the color of the AP indicates the switch that it's connected to. So this allows you to see, do I have clusters of switches, and I can turn on like, a heat map, and okay, let's say I lose my blue switch. So I'm going to lose some coverage, at the bottom part there. And this has actually worked really well. This works with Juniper switches, third-party switches, doesn't matter. This has worked really well for us and has helped customers deploy like a salt and pepper type deployment where AP1 connected to switch 1, AP2, which is right next to it, is connected to switch 2. And this has worked. This is, like I said, this has worked really well, but it requires you to look at the map to verify. And so what we're introducing is a redundancy view. And so if you look, the colors have changed basically to green, orange, and red. And what this actually means is if I'm red, my top neighbor is connected to the same switch. If I'm orange, I have at least one neighbor that's connected to a different switch. If I'm green, then I have 2 neighbors connected to different switches. And the point of this is, yeah, we're showing it on the map, you can visualize it, but we're assigning a redundancy score to the site, to the switch, to the AP, so that you can pull this programmatically to identify your sites or locations that have the worst redundancy capabilities. So we're basically marrying our like the switch uplink data that we've had with radio resource management data to actually determine from an RF perspective what is your redundancy if you were to lose a switch. And where this is really exciting is we're working on some improvements to our switch upgrades, and we will actually feed this data into our switch upgrades to say, if you've deployed redundantly, I can reboot my switches in such a way that I still have Wi-Fi coverage. Right? So you can have a hitless edge upgrade, which is very, very cool to me.
Well, so the switch will automatically determine which, like, if I have a stack of like 4 switches and I have obviously APs connected redundantly, so the switches will automatically figure out which one I should reboot.
The cloud will, and the cloud
will. Sorry, yeah. So the cloud will tell them, hey, you should reboot first. And okay,
Yep.
Oh, that's cool.
Okay. Yeah. So this is I think something we're excited about, and we've seen folks try to deploy redundantly. So here's one example of kind of a not so great example, but working with the best that you have. These APs in the line, right? So like at the end when I can hear other APs, they're orange, but in the middle of the truss they're red, right? So because there's no right, but this is a special case deployment. Here's an actual example of it done well. So here is the top is the APs by switch. So the different colors represent different switches. And so in this particular example, most of the APs are connected to different switches that are next to each other. And the bottom is the redundancy view. And basically everywhere is green. So there's very high redundancy. This guy in the bottom left, if you look, right, that's this yellow AP, and kind of these two are the same switch around it, right? So yeah, Keith.
Do you know if this customer thought about this before they?
This customer did, yes, they absolutely did.
Because fixing it, if you got a bad one, might be a pretty expensive option.
So what we've seen is this is something you're thinking about at the time of deployment. And the switch redundancy view, like the redundancy score, allows you to audit. Have you done what you thought you've done?
That seems like a lot of APs in that office space.
It's a big office. It's bigger than it looks.
Okay.
But it could also be a dense deployment. Okay, so let's talk a little bit about RF troubleshooting in Mist. So in Mist, we have several capabilities of troubleshooting capacity and RF issues. So the capacity SLE in Mist is one such way, and there's if you can see, there's classifiers here, and these classifiers will figure out, is it me that's transmitting, like one of my clients? Is it because of the number of clients has increased, the usage has increased? Is it like a co-channel neighbor, APs on the same channel, or is it non-Wi-Fi interference? Right. So we bucketize, and RRM actually uses this data to make its determination. And same thing, there's a channel occupancy view. So in this case, there's basically an interference source. This interference source on 6 gigahertz channel 5, actually between channel 1 and channel 5. And what we have seen is RRM will actually channelize around this. So oftentimes our customers are not actually aware that there's interference in the environment, until they go track it down. What I'm going to introduce now is our spectrum visibility. So first and foremost, I'll just say MIST is supporting a manual spectrum capture like you would fully expect. But what I'm going to actually talk about here is what we call dynamic spectrum capture. So this is the ability of, let's say there's an interference source and RRM changes its channel, right? We're avoiding it. Wouldn't it be cool to see, yeah, there's actually an interfere, and this is what it looked like. That's what we're doing.
Yes, it would be cool. But before you get how, here's the question.
Yeah, so I mean, the AP has a lot of metrics and knows, it knows when there's interference, right? And so with that, we will use a kind of a combination of both AP level and cloud assist. There'll be different workflows, but to actually then trigger spectrum capture on the AP itself. The hardware is capable. We have not yet enabled it, but that's what we're doing now.
Is there an additional radio taking care of that, or you're disabling the Wi-Fi functionality so you look at the spectrum at that time?
No, so every MIST AP has a built-in scanning radio, security radio. We'll do the spectrum captures from that dedicated radio.
What's the level of resolution?
Currently, it's 312.5 kilohertz, but this one is actually, we have some flexibility to tweak, right? So we're not going to win any awards with resolution.
Everybody asked.
But it's
Asked it.
And this has been inside just waiting for the software to catch up to it. Stealthy.
So let me show what this
Does this work on 6 gigahertz as well?
Oh, thank you for asking. So I have this device here. This is a Teradek video transmitter. It operates on 5 gigahertz. It operates on 6 gigahertz. It is a 6 gigahertz interferer. So there's a receiver that I have in my box of goodies, but I'm not going to turn it on. So earlier, I've actually triggered, I've turned this on, and this is kind of how we intend things to look. So, I have an RRM radio event here. This AP changed channel from channel 5 to channel 21. It did it because of interference, non-Wi-Fi, right? And here is an FFT. This will change. This will actually, this is kind of like a kid drawing right now, but this will look a lot nicer. But this is the intention, right? I want to capture what this interference looks like so that you can go and look at it, and then we can start doing, a lot of cool things with this data once we have it. Classification, yeah. I don't think anybody has really done classification, at least Wi-Fi vendor side, well. So, we're thinking about, can we crowdsource,
Trouble ticket suppression to let the people at the help desk know if you get a call, don't freak out.
Correct.
We saw a thing.
Yep.
It's all
Baby
cool.
monitor.
Yep.
This will also be in Marvis actions also, right?
Yeah, this will come into Marvis actions. Yep.
Cool.
Yeah. So that's this is the thing that I'm most excited about today. We've put a lot of effort into it. We still have some effort left. Full disclosure, this won't be available immediately. But this is the idea. We're actually capturing a couple seconds of the spectrum capture. So we can enhance the graph that you see here to put in density type of data. We could also potentially do like a video or a GIF. But yeah, there's a lot of potential for this, and I'm really excited.
Would customers be able to label their own interference? So I've got a conference center. I know the AV crap steps on my stuff all day. Can I just label that waveform, this is AV crap.
Yep, that's what. So that's one of the things that we're thinking about is to let customers label their own interferers, right? Because one of the tough things about classification is keeping updated on the interference sources, right? Everything says video camera or
Microwave
or
monitor.
TDD. Right?
Wes,
Lightning sensors. Light
once
sensors.
these signatures are recorded in a location, is this beneficial just for that location, or will this benefit like other customers outside of that organization?
So those are things that we're still working through. We can do our kind of classification labeling in two ways, right? We can keep it customer specific, and some customers may want that, but we can also use it as a crowdsource where we're building our classification stuff. Yep.
This is from AAP.
Yes.
How do you handle, a lot of interferers would have a larger blast radius?
Yes.
Could you use this with your mist cloud to not triangulate, but at least give you a who sees it worse?
Correct. Yeah. So yes, that's the intention. We want to get to a kind of a point where we can try to put this on a map, and we can use the scan radio, like we're using the scan radio. And the reason we're detecting is because that particular AP has been interfered with, but then we can, from the cloud, we can trigger other APs. Right?
Question, are you able to connect with any third-party tools to look at this, like Wi-Fi Explorer or something?
So we have been in talks with some of the tool vendors around exposing this data to them, especially in the the dynamic piece as well as when we get to the manual piece. Both of those to expose those in third-party tools, but nothing to announce at this point.
If multiple APs see the same interferer, do you get multiple events, or do you correlate those and just report once?
So in this particular view, it will be AP by AP, but the intention is then when we bubble up into Marvis actions, it would be consolidated.
And then you can triangulate where that interferer is coming from. Can I hang it around my neck and walk around and do a site survey with it?
Any chance to be able to do like on demand or something like that? If somebody wants to just like Marvis Minis, right? You can do like a manual test or something like that.
Yes.
Is there something like that?
Yeah, correct. I'm not showing it here, but yes.
Okay.
Yes. Cool. Okay. So then, so a few more things from Marvis action standpoint. We're introducing a couple of new Marvis actions. One is a traffic loop Marvis action. So this is combining the AP reflection data that we've had for a long time. So if any of you are MIST users, you may have seen AP reflection. That's the AP hearing its own frames, and we can marry that with or without switch data to provide a switch. An AP loop detected, and then second is when APs disconnect from MIST, we usually get a customer ticket, and that customer ticket is, hey, are you having an issue? Especially if it's a large outage and a large customer. But most of the time, not all the time, most of the time, it's an ISP issue, and so we will do ISP correlation automatically. We're actually already doing this internally, but we're going to expose this as part of the AP offline Marvis action. This is an ISP issue, and this is the ISP that was causing your problem. And this is particularly relevant for our larger customers who have many sites or locations. So from just to kind of give a little bit of a demo, here is the AP loop detected, and this is the switch that the AP is connected to, right? To say, yep, this is where the this is where you need to look, for that loop. And then the MSP or the ISP view. So if you see kind of down here, there's this 16 APs in this site went offline due to an ISP issue. And I froze. Awesome.
Question about your loop detection.
Yep.
Does it replace the AP reflection, or?
So just like all of our alerts, you have some of the, let's call them the unfiltered alerts, and then those go into Marvis actions. That's the kind of higher efficacy. It doesn't replace the existing, but it's a higher efficacy alert.
Okay.
So in this case, there's a AT&T Internet ISP that was correlated. Okay, lastly, I just want to say we have introduced a new missed edge. It's the X6, 100 gig of throughput, 4 10/25 gig ports. And this will be the backbone of many of our campus deployments coming up.
I have a couple questions from online.
Sure.
First was, does redundancy option care about switch and switch stack members?
Yes. So I didn't show it, but if you look closely on the map, some of the switches actually had S1 and S2. Those are switches in stacks, member 1, member 2.
Okay. And any idea of when the RF spectrums
Yep.
going to roll out?
Second half of this year.
Got one online question also. Does the extra radio do both spectrum and frame capturing simultaneously or
No.
sequentially?
Sequentially. Okay. One last thing. Let's talk about some Hamina stuff. How about that with Mist?
So previously on Juniper and Hamina, we've done a lot of integrations. You can auto-deploy directly from Hamina to Juniper. Many don't know this, but actually, Hamina can automatically create the sites, deploy the APs. You can also import from Juniper back to Hamina, things of that nature. It's pretty amazing. It uses like 1 billion API calls. So that's already there today. And this is what we're going to talk about. Is a Q2 announcement. Actually, Mist has started to deploy these API changes already, and we will release the product still during Q2. So this is more on the day 2 and beyond kind of a scenario, more specifically troubleshooting. If we look at troubleshooting, it could be a hairy issue where different levels of network engineers are involved, and different things are made at different times, and the issue kind of gets escalated, to more and more of an expert person. And it can be pretty hairy. And then on the other side, there's an increasing amount, we've heard about this today, where, the dream scenario where Marvis solves the ticket and case is closed, and IT administrator can just kick back and relax, all right? So usually it's somewhere in between, or often it's somewhere in between, okay? But the challenge is, this is the first time anyone looks at RF is when you do a truck roll, right? And you actually get a visibility on the RF and a visual map representation. So we thought we would add live RF analysis earlier up the stack. And so let's take an example, picture an office with some Wi-Fi problems, all right? There might be a high-speed roaming problem. There's an executive CEO running around the office with, I don't know, apparently both a wireless and a wired headset, and he's having some roaming problem. Maybe it's somebody prepping for a board meeting. He's actually so effective, he's using 2 laptops apparently. But beside the point, in the staircase, there's a coverage problem. Okay, so there's a roaming problem, staircase coverage. And also, in the out fringe areas of the offices, people are, used to using internet for important things, and it just doesn't work. So let's look at how to visualize that actually from a live network. And this comes through the integration, all right? So the challenge here is, when we looked at the simulation, okay, when we designed the network, everything was working great. We placed the APs where they're supposed to go, and everything is all good and green. All right. When we did the site survey, everything was good and green. So these bathroom areas where the selfies are being taken, the important work is being done, all green. But then in the live situation, actually, it's not that great. What just happened? How did we get to live here? So we tapped into the Mist infrastructure. We pull in all the data we can, RF data, channels, channel widths, everything about the Mist network using the API. All the user needs to do is put the API key in once, and he gets a live view of the network, all right? So coverage seems to be low here. Let's look at secondary coverage. Maybe we can find the holes, because this was the problematic. Yep, this was the problematic area for the roaming CEO. So there's definitely problems there. Again, live data with the current up to this second settings. Okay, this is not how it was simulated, not how it was surveyed. All coming through the Mist APIs. So these kind of problems, I actually discovered the problem. I do know personally the guy who was testing on this site and left the power to manual and to minimal setting. Okay, so this was just a typical like human error transmit power snafu, and this may have been preceded by a coverage hole detection event from Marvis. So it's kind of like Marvis action comes in. If you want to take a closer look, you investigate it in Hamina.
So is this using is this quick question? Is this using the beam density map or maps and stuff?
This is using missed RRM data.
Okay.
Yep. And so okay, that was the misconfiguration and easy problem, fix the RF level, stuff like that. What about the guy in the staircase? Remember? So what? This obviously isn't a configuration problem. It's an AP placement problem. What we can do is just from the live view, we copy and paste the APs to the simulation. And let's look at primary coverage. Okay, so now we've kind of pasted the exact live situation into our simulation. And how do we fix it? Well, this is an obvious case, right? You just place an AP, but you can copy your current situation and do changes, using just that. Now, okay, your next question is like, okay, you have full stack Hamina experience here, and you've you put in all the walls and kind of did the network plan and survey and stuff like that. Do I really need all of that? Do I need the surveys? Do I need the walls? Do I need everything for this to work? And the answer today is no, you do not. And this is the new thing, like we're announcing today, and that Wes deployed actually last week. So we're deploying also, Wes is deploying AP to AP mapping. So using the RRM data, all the APs can hear all the APs. So we're getting also those stats into Hamina as well. And with all the new data that Wes is collecting, we can now do environment learning automatically. So you do not, on an existing site, if you want to see accurately the RF or simulate changes, you do not need the walls. All you need to do is open Hamina, click import to Hamina, and there you go. So let me take a site that has absolutely no walls, nothing like that. Check this out. So usually, if you have no walls, you have nothing, you get this like, completely circular coverage pattern. I don't know if you can see this very well live over Zoom, but and here's like offices and staircases. So that's where the signal attenuates. And as I move the AP, you can see it's anything but circular because it has learned the environment, okay? And if we move the AP to an open space, the coverage area is much, much larger. So take all the missed data, do some prediction math, and learn the environment. You don't every time need the walls to see accurate heat maps. So that's kind of some of the new stuff we're bringing. The live view and also dynamic environment learning.
Okay, you see, that is awesome. Thank you.
That would be use case like an augmentation of an existing site?
Yep. The live view you can use, of course, for anything. Primary use case is troubleshooting, but the environment learning is augment any site, and there you go. Also, more accurate RF troubleshooting for coverage, interference, secondary coverage, everything.